So welcome everyone once again to the workshop for cities. XAIDA, if you didn't know, stands for Extreme Events, Artificial Intelligence for Detection and Attribution. So I'm now going to just highlight detection and attribution, what that means. So the field of attribution is relatively new compared to many other fields in science. And the first papers came out in 2004 following a very extreme heat wave in Europe in 2003. And there we looked at, the researchers then looked at a very large area and seasonal means. And since then, we've come a long, long way. The field is advancing rapidly, but most interest in extreme events and attribution happens following an extreme event. For example, this record-shattering heat wave in the Pacific Northwest in 2021. And then two questions typically arise. Are these events or events like these changing in frequency or magnitude? And to what extent is that change attributable to climate change or to some other factor? And we call these two questions detection and attribution. So the detection question is answered by looking at observations. And here you can see for this particular heat wave, then we've shifted from looking at whole seasons to annual maxima. But there's still a lot of natural variability. And the question we address in detection is, can we detect a climate change signal, a trend, despite the natural variability? Can we detect that? And you can see the events up here, very, very, very extreme. This is the time series against time, but often it's more helpful to look at the time series against GMST. But to really understand if it's due to climate change or not, or some other factor, then we need to use climate change models. Oops. There we go. So you can see the same kind of plot here, but using models, and there's of course a lot more data. So the signal to noise ratio is often clearer. And you've got the control experiment. You can run a model with or without climate change effects. And then, of course, there's a third aspect of projection that many attribution studies look into, because climate models don't stop at today's climate, but they go into the future. And then you can make comparisons between some future date and now, instead of just comparing now to the past. So what is XAIDA? It's a 4-year EU-funded project. It unites 16 climate research institutes within Europe. We're developing new artificial intelligence methods to study how global warming affects extreme weather worldwide. And we're advancing the detection and attribution techniques for low resolution, noisy data, compound events, or unseen events. And further on, we're also looking into new impact-based event definitions and collaborating with a range of stakeholders to develop new educational material. I think somehow I have skipped a slide. Yeah. So the answer to the attribution question is not a given, and it's this that XAIDA wants to explore. So attribution answer depends on the event definition. So the atmospheric or climate variables that you look at, the temporal and the spatial scale, where the event occurs. As you can see in this figure on the right, for precipitation, there are many areas in the world that just don't have sufficient observations. These dots show observations with at least 50 years of data or more. So the amount of data and the quality of data is very important. And the more extreme, the more uncertain are the statistics. And sometimes we find that formal attribution is just not possible due to poor quality data or just too much variability, which is linked to the variable you're looking at and the location. So the rest of the workshop outline will be 5-minute presentations and 10-minute questions. And we'll start with Eric Fischer from ETH Zurich, who will introduce ensemble boosting for as yet unseen scenarios. And then Robert Viltard will present the hard case storyline for the Paris 50 degrees case. And then Pascal will go further with that, showing how you can simulate unprecedented events with a stochastic weather generator. And then at the end, we'll have some open discussion and feedback. So with that, I'll hand over to Eric.